to prove a root lies between two numbers a and b. Calculate the function substituting in a and the function substituting in b. If f of a and f of b are different signs, i.e. one's positive and one's negative, and the function is continuous, then there is a root. So an example of a function that wouldn't be continuous would be tan x, which is not joined up, i.e. not continuous. So that 2x cubed minus 4x minus 5 has a root in the interval 1.8 to 1.9. Start by finding out the function substituting in 1.8, so that's 2 times 1.8 cubed minus 4 times 1.8 minus 5. And if we put that into the calculator, we get minus 0.536. Do the same again with 1.9. That gives us 1.118. And so we've got the sign change that we need to prove a root. And of course the x cubed graph is a continuous graph, so we've got both conditions met. Use the iteration formula x equals the cube root of 4x plus 5 over 2 with x0 equals 1.8 to find a more accurate root of 2x cubed minus 4x minus 5 to 2 decimal places. Start by substituting x0 equals 1.8 into the formula. We want 4 times 1.8 plus 5 over 2. This equals 1.82716. I'm just going to take the first 5 digits. So our first approximation is 1.82716. Now we're going to replace the x0 value 1.8 that we had in the calculator with the ANS, the answer button, and then just press equals. So we just go back through, take out the 1.8. As I said, we replace it by pressing the answer button and then just hit equals, and that will give us our next approximation, which is 1.83256. So you just keep on pressing the equals button now and recording each time you get a new approximation until you've got 3 that are the same, rounded in this case to 2 decimal places. So let me write these values out again so it makes it a bit clearer. So we've got x1 equals 1.82716, x2 equals 1.83256, x3 equals 1.83364, x4 equals 1.83385. So I've tried to put that line in to help you focus on the 2 decimal places, and what you'll see is that x2, x3 and x4 all round to 1.83 to 2 decimal places, and so that's our root. To create an iteration formula, rearrange the equation so that you have just x equals whatever on the side. you usually will be told to show that it becomes x equals something specific, because there is more than one way to rearrange an equation. Watch out, some formulas don't converge on a root, they diverge, and some stop working. For example, if they might involve a square root with a negative, then it wouldn't work anymore. Let's see how I got the iteration formula we've just used. So we're starting with 2x cubed minus 4x minus 5 equals 0. So let's rearrange that to work towards getting x cubed on its own, because we know that the iteration formula was a root 3. So 2x cubed equals 4x plus 5. X cubed equals 4x plus 5 over 2, and therefore x equals the cube root of 4x plus 5 all over 2. Now, an alternate way we could rearrange it would be to get just the little x on its own. So we'd have 2x cubed minus 5 equals 4x, and that then leads to 2x cubed minus 5 over 4 equals x. Now, if you try that formula, starting with x0 equals 1.8 again, you'll find that it doesn't converge. x1 is 1.666, x2 equals 1.06203, x3 equals minus 0.65105, x4 equals minus 1.38797. So you can see they're all over the place. If you are asked to show that a root is correct to a certain level of accuracy, first, find the upper and lower bounds. Second, substitute these values into the function. Then, if the signs are different and the function is continuous, it is correct. Show that x equals 3.065 is a root of the equation x cubed minus 2x squared minus 10 equals 0 to 3 decimal places. So first let's find the upper and lower bounds. Put the 3.065 in the middle, and then we go up 1 to 3.066 and down 1 to 3.064. Halfway we get 3.0645, which is the lower bound, and 3.0655, which is the upper bound. We now substitute in the lower bound value. We get minus 0.0031099138875, and if we substitute in the upper bound value, we get 0.012812761138. So we can see that there's been a change of sign, and because x cubed is a continuous graph, this is a root.